So you guys should see my Canvas site at this point. Let me just go to Canvas for the lab. Again, you can see that these are where the announcements are. If you want to see the thread of announcement, just click on that, and then you can see all the announcement that I posted, which is quite a lot actually for a week and a half. I also want to point to the feature that I just added. I put in here a way to access my website. You can click here. The Google Drive. Google Drive has the lab manual as well as any PowerPoint that I might have. You can just access it directly there. And then the lab manual. So this is the lab manual. The other lab manual that I had, it's called Flipbooks. And I was just doing it for trial because I didn't pay the subscription, which was about $200 a year. Didn't really have money to do that. But so I tried it. I really liked it, but I wasn't going to pay $200 a year just for you guys to see this. So I found this other site, and yeah, it's got ad, but if you just click here on full screen or even here in large screen, then you can pretty much see the lab manual, just like the other site. Okay, so I want to go over here to experiment number one because that's what we are going to be doing, this part right here, the penny lab. So I'm just gonna bookmark that. Let me go back over here and remind you about what's coming due. So if you go to the module, you'll see that the syllabus quiz is due. So make sure that you complete that by the 16th. That's next Tuesday. And then there's also a safety quiz. And I believe the safety quiz is right here. Watch the safety video and then take the safety quiz right here. And that's due on the 16th as well. Okay. You guys have an activity that's based on math basics, doing exponential notation, rounding off, expressing things scientific notation, and then calculating dimensional analysis. So that's here, right here. If you want to see the technique of dimensional analysis, I found this really good YouTube video, but this right here, remember, is due on the 15th. That's, I believe that's a Monday, okay? Remember that Friday and Monday are holidays. So if you have a regular meeting on campus through Zoom, then don't attend those because those are going to be canceled because Friday and Monday are President's Day. So this right here is, it's got two dates. It has a due date on the 14th, but you can turn it in as late as the 15th. Okay. If you turn it in on time, I give you bonus points. If you turn it in by the until date, then I don't take away any penalty, but you do have that extra day just in case. So this right here is the same that you would see right here on activity 1. It's basically these pages. Okay, but let me just forewarn you that even though these numbers are here, you need to complete activity 1 on Canvas. Okay, you need to put your answers here. These are just to give you a preview of what the question might look like. And the other thing I want to mention, I think in this particular case, practically all the numbers, except for the dimensional analysis, are identical to the lab manual. Okay, this and this are identical, but it's been known to change. And the reason why we change it is because the lab manual has been out now for a couple of years, and students just sort of share their previous work. And it's been known that some students will just put in the answers without working it through. So to keep you guys honest, sometimes we change this. But the first part of this activity is just rounding off. Remember that the first digit after the decimal is called the 10th. The second is called the 100th. The third is the 1000th. The fourth is the 10th of 1000th. So when it tells you to round off to the 10th, so you're rounding it off to 21.4 or 21.5 because you got to round that number 4 to 5, because if you look at the next series of numbers, these right here, that is 6,499. If it's higher than 5,000, then you have to round up. If it's below 5,000, then you retain that number. So when you're rounding, always look like right here, if I'm rounding this off to the 10th, always look at the whole number right here and see whether or not it's above or below the halfway mark. So this is a 106, halfway would be 500. Okay, so that's the general rule of thumb when you're rounding off. Don't just look at the next digit over, look at the whole thing and see whether or not it's 5 or above, or 499 and below. Okay, that's what you are looking for. Anyway, that's question 1. Question 2 is significant figures. How many significant figures do these things contain? The next one is, I believe you're going to be writing these things in exponential notation. It's important that you pay attention to the directions, because rather than typing in times 10 and then the exponent superscript, you're just typing in E and then the exponent 23. You're always going to use that nomenclature when you have a computer. Okay, so something like this would be 6.7 e to the 4th. Okay, that would be like 6.7 e to the 4th. Don't write 6.7 times 10 to the 4th, because that's not the notation that's in the directions here. The rest of these are addition, multiplication, the rules for doing that. Okay, and then you get to conversion factors. Make sure that you go to, when you use that, go back over here and use this page in order to determine what conversion, because conversion factors actually vary from book to book. And so in order to be consistent, because remember that when Canvas grades things, it does so with based on what's been pre-programmed. So when you go to, I believe it's this one right here, use this appendix as your source for the conversion factor. Okay, use that instead of looking it up, because some book will say 1 pound is 453.56. Okay, we don't want that, because when I program the answer in Canvas, I'm using this conversion factor. So just a little tidbit of information. So the rest of that particular activity is just doing the math, and then it'll be graded based on your answer. And then you can see whether or not you're on top of things in terms of, I always got to go back to the module. You have the math that is necessary for the rest of the class. Okay, so that's math basics right here. So you guys should be able to see that in terms of that. I think we are good now. Okay. Let's see. The last part here, let me just explain this, our dimensional analysis. Show your work and then upload your work, I believe. And then this one is a very tedious problem, but it shows you how dimensional analysis work. This is the formula that you guys will be using, okay, in order to convert seconds, because remember this question is about, it takes about 8 minutes and 15 seconds from light to go from the sun to the surface of the planet. So we're using the speed of light to measure distance, but we're using the size of a penny as the distance barometer here. So I've shown you through this setup right here how to do dimensional analysis. Notice that seconds will cancel with seconds, miles will cancel with miles, feet will cancel with feet, inches cancels with inches, centimeters cancel with centimeters, millimeters cancel with millimeters, and you get pennies as your answer. That's the heart of dimensional analysis. So I set this up for you. So over here in the bottom, and you notice it runs out. And the reason why it runs out is because my screen is too small. I need to stretch it out, or I need to make my window smaller. And when I make my window smaller, then I can see everything. So that's what you have to do in your computer. If your resolution is poor, make sure you scroll or you decrease by command plus or minus to make it smaller. Now you can see. And the question is, what is the seconds for 8 minutes and 15 seconds? You want to put that in there. And what is the conversion between miles and seconds? That's this right here. And what's the conversion factor between miles and feet? That's this conversion factor right here. And what's the conversion factor between feet and inches? That's this conversion factor right here. And if you do that all out, you've done dimensional analysis. And all you got to do is the math, where all the numbers in the numerator you multiply, and all the numbers in the denominator you divide. Okay, so this problem, if you are not used to dimensional analysis, is quite daunting in that it can be confusing. But you can see here, again, the power of dimensional analysis, that any problem can be solved if you let the units work for you. And this will pay dividend, especially when you get to chapter 7, when we do stoichiometry. Because stoichiometry is not about memorizing how you go from grams to moles or from moles to molecules. It's actually about using dimensional analysis so you can tailor the numbers to solve the stoichiometry problem. So if you invest some time understanding dimensional analysis really well in this chapter, it'll be amazing how much more easier chapter 7 becomes. And again, like I said, review this right here so you understand the techniques of dimensional analysis. Right here is a dimensional analysis tutorial. I thought this was really good. They always give you a commercial if you don't pay for these things. So just skip. Can help.
This sentence is grammatically.
Let's skip. And then these
Learn
guys.
Unit conversion the easy way. We're going to start with a simple unit. Include the units in the calculation itself. The quantity we are starting out with, 5 divided by 2.2, and your calculator should tell you the answer is 225. Our final answer, therefore, is 225 kilograms. There is one more thing that we should notice about this problem.
So again, just watch it. It's not a very long video, 6 minutes at the most, but it really teaches the power of dimensional analysis. Okay. So for some problems, how are you supposed to upload your work? Let me just take a look at that real quick. I think for this right here, there should be a question at the end where you take a photo of everything and then just upload your work. So let me just see that. Actually, I forgot to add that. So there'll be one question at the end here where you can just take a picture of your work and then upload it. Okay, I forgot to put that in. But most activities will involve where you write things on paper and you upload your work. Actually, let's not worry about that. You guys just put the answer for this one, since I forgot. It's not necessary to show your work for this one, but for the next one, you should. Yes, there was a question. Go ahead and unmute yourself if you have a question.
Yes, so we would be entering the answers directly into the Canvas?
Yeah.
Oh.
Yeah.
Okay.
You do that. But be careful, because see this number 36.17, that's not the number that you have in Canvas. Okay, if you look at this one right here, this question is that problem is 65 miles per hour. So make sure that you pay attention to the numbers that are in Canvas, because remember that in Canvas, it's based on the number that is there. That's why you don't need to upload your work for this one. Okay. So that takes care of things that are due. Remember, 3 things: activity 1, that's just the math, safety quiz, and the syllabus quiz. So this is the PowerPoint that is available in Google Docs as well as in Canvas. Anyway, it talks about the scientific methods, the different parts of the scientific method, and that's because that's what this experiment's about. Okay, you have an observation right here, you have a hypothesis right here, you have a prediction of what's going to happen, you have your experiment, and then this keeps cycling until the hypothesis is really proven valid. And then if you prove the hypothesis enough times, then that becomes a theory, in which case you continue to do the same thing. You take your theory, you have a question on the theory, you do some research and experiments, you maybe extrapolate. So these are the parts of things for us to acquire and organize knowledge. Anyway, so this just tells you about the experiments. The question that we're going to ask is how, oops, sorry. How does the weight of the penny change with age? And you can take one of 2 stance. One is that it gets heavier, and you have to not just say it's heavier. You have to explain why it might be heavier. So that's the start of this experiment. Okay, you guys are going to get old pennies and new pennies, and I'll show you how to do that. And you're going to propose a hypothesis, and then you're going to graph it. Now, this is a graph that might be for the whole class if we were doing this on campus. But since we're not, you guys are just going to graph data of 10. You're going to graph it, and then you're going to see whether it's consistent. Remember that over here, these are older pennies and these are newer pennies. So if you want to say that older pennies are heavier, you would see a trend line that looks like this. Newer pennies are lighter than older pennies, but your hypothesis is older pennies are heavier. If you want to say that older pennies are lighter, then you would see a trend line that looks like this, where the older pennies weigh less than the newer pennies. Remember that this is time minted. So that's essentially what you guys are going to do with your 10 data points. And then this is the data set that you guys are going to be collecting. Okay, so let me just show you how that's done. Remember that you guys are going to be doing the year, the mass, the diameter, the thickness, and the condition. So I'm going to switch cameras, and let me just see. This is so you should see my desk right now, and here are my coins. Okay, I was able to dig out some coins. I actually have more, but I found enough of the pennies. This is my scale. The first thing that you want to do is make sure it works. And then you want to turn it on right here, and it should turn blue. And then it's very important that if you look, let me zoom in. Okay. Let me zoom in here. That this thing reads grams, because if you do mode, it can be ounces. Oops, that's where my finger is. And I know that it's very hard to see that because it's blurry. That's because the camera that I have overhead is not a high-res camera, but it's good enough. Or it can do GN, grains, and it can do carat. If you got a diamond ring, you can weigh it. But you want grams. Okay, make sure it's grams because we want to do that. Then the other thing that you could do is, in order to protect the surface, you can put a weighing boat. I just have a Chem wipe here, but the Chem wipe is going to waste. When you tear it, it basically zeroes the balance. That's what TARE it means. It means to zero the balance. Now, if I put a weighing boat here, or in this particular case, just a tissue to protect the balance, you notice that the tissue weighs 0.47 grams. I want to zero that because I don't want the mass of the tissue or the weighing boat to interfere with my mass. And so what it does is it zeroes it. And now I can put the penny. Here's a penny. You want to make sure that you don't handle it with your fingers, because even the oils in your fingers change the mass. Not that we're doing any real science work, but this is good practice. And then I just put it here, and then it'll record the mass to the 100th of a gram. This particular penny, it's 3.14 grams, okay? And what I want to do is put it aside, and then I also want to record the year. This happens to be a 1972 penny. This happens to be in 1972. So what you want to do is you want to start with the oldest and go with the newer ones. So let me just go to the lab book. So right here, if you change my screen here. Okay, so you can see in the lab book here that, let me blow this up. That's the data that you guys are going to be collecting. First, write your hypothesis up here. Okay, and then oldest to the newest. What is the year? 1972 for me. What is the mass? 3.1, what was that? I forgot. 3.14. Okay, here it is. In this case, it's 3.13. The diameter is going to be this. What you need is a ruler. And the ruler will be, you guys all have a ruler. So let me go ahead and remove this. And what you guys are going to be doing is you're going to be the diameter. Make sure that when you use the ruler, show you this. Okay. Make sure that when you use the ruler, you use the metric side and not the inch side. If you do it by inches, you're going to be wrong. Yeah, exactly. Thank you. Look, you got the ruler. Okay. And then don't measure it at the beginning. Just measure it somewhere in the middle. That's 4. And then you just count. This from 4 to 5 is 1 centimeter. And then from 5 to 6 is 2 centimeters. So it's less than 2 centimeters. So it's 1 point, and then you just put it there, and then you just have it stay still, and then you just read that diameter. Okay. Remember, the diameter is across, and find the longest distance. Don't like measure the diameter at the bottom or the top. You got to find the halfway point and then measure the diameter. And then the next measurement that you guys are going to be doing is you guys have got to measure the thickness. Again, you just stick it there and you just measure the thickness. You don't have to put it in the beginning. You can stick it anywhere in the end, but know that that'll be the 0 line. And then you just measure it, and try and measure it in centimeters, not in millimeters, even though each of these lines are millimeters. So if it pass one line and hits the next line, that'll be 0.2 centimeters. If it goes from one to the second one, it will be 0.2 centimeters, okay? Or 2 millimeters. 2 millimeters is 0.2 centimeters. Anyway, you're measuring the thickness, okay? And the reason why you want to measure in centimeters is because when you take a centimeter and you multiply it by another centimeter, and you multiply it by a centimeter cube, or cc, a cc or centimeter cube is a milliliter, okay? And that's ultimately the volume that you're going to use in the next step. So let's go back over here. That's basically what you are doing. I mean, it's pretty simple. You've got the year, you've got the mass, you've got the diameter, you've got the thickness, centimeters right here, and then the condition.
Uh,
Is
uh,
it
Professor
shiny?
Garces,
Yes.
for the thickness, when you said to measure in centimeter,
Yeah.
is it only in one sig fig or two sig fig? Does that matter?
Remember that the ruler, remember I told you the ruler is 0.01 centimeters. So it's going to have the same degree of precision. Okay. You're going to measure it out to two decimal places
Okay.
because
Thank
it's the
you.
same ruler. It's the same ruler. So it's going to have the same precision. Good question. So if you take a look at this penny, you're going to see that you're going to write a little description. It doesn't have to be a whole thesis about the condition. That's one type of penny. This is another. And you can see that one is kind of shiny. It's got some luster to it. The other one's kind of dull. If you look real closely, they got some sort of dirt in his face and all that. So those are the little things that you're going to be writing down for the individual pennies. And then you're done. You're done with this first part. I mean, it's pretty straightforward. Take a seat and then start graphing it. If you don't have 1960, fine. But all of these, and then remember we are in 2021, that probably if you can find a 2021 penny. But all of these are like 10 years, you just sort of graph it, and then you see what the trend is. Is it steadily going down? Is it steadily going up? Is it straight across? Does it validate your hypothesis? Now, let me point out a couple of things for this experiment. Read the direction. It says label the graph below with proper labels. A lot of you will just put your lines here and then forget about it. The labels are going to be the year minted and then the mass. So these are little things that you need to put down because as a scientist, you got to pay attention to the details. Okay. And then right here, what is the conclusion based on the graph? Is there unexpected result, or does the graph actually validate your hypothesis? Is your hypothesis consistent with the graph, and is there something unexpected that the graph shows? Okay, so that's part one. Then we get to part two. I'm going to let you guys know ahead of time that you actually find an unexpected result. Okay, so that's not really how science is done. Science is done where you have a hypothesis, you test it, and then voila, you have a eureka moment. You find out that oh my data is really messed up. There's something else going on, and that's how people discovered penicillin. The story of penicillin is that it was an accidental discovery. It was what we call a eureka moment. A guy by the name of Fleming had a dirty lab, and he had petri dish everywhere with colonies of bacteria. And it was because of his dirty lab that they discovered penicillin. What he was doing was he was giving a tour to this person, very important person of his lab, and there was just dishes and petri dishes everywhere. But he noticed that one petri dish, the colonies that were growing in there was wiped out. It was clean on one side and then colonies on the other. So I said, I don't know what's going on here, but he put it aside. And then later on, when he had time, he looked back on it and says, something's killing the bacteria in this colony right here. And he found out that it was contaminated with the spores from the lab downstairs. It had gone airborne and hit his petri dish. And even though he actually discovered penicillin, but he was not the person who was able to synthesize it and isolate it. Someone else did that. But these days, we do give Fleming the credit in terms of getting penicillin. And penicillin is really important because without penicillin, we wouldn't have antibiotics. And a lot of people in the war would have been dead without that. And so it led to a new science of antibiotics where we can cure a lot of bacterial infection. But it's things like that in science that the unexpected results that is really the gateway for a lot of discoveries. And I think Einstein said it best. The great discovery will go to the prepared mind, and it's the person, they'll not dismiss it. They'll look at it in a second nature, and if they are prepared, they'll make the connection and then fill in the dots. Anyway, that is a story I usually give if we were meeting. So the second part of this lab will require you to find more pennies, at least 10. If you can't find 25, at least 10 old ones and 10 new ones. That's a good sampling, okay? At least 10. And then the common mistake that you guys will do is that you will think that the density of the 10 pennies is the density of 1 penny, or vice versa, okay? And let me just make sure that you are clear in how to do some of these problems. Anyway, these are the directions for the second part. The second part, you are going to write a new hypothesis. You are going to determine the density of the pennies, the old one versus the new one. So you take a stack of old pennies, 1980, 1981 and older. You take it, and then you take a graduated cylinder, 100 ml graduated cylinder, and fill it to the 20 milliliter mark. Okay, and then what you do is you slide those 10 pennies or 25 pennies inside the graduated cylinder, and the displacement when the water level rises, maybe goes from 20.0 to 25.3. Well, 25.3 minus 20, that volume, 5.3, is the volume of the pennies, because the water will always be displaced based on the volume that is in there. So you have to take the difference, okay? If you start at 20 and it goes up to 27.8, 27.8 minus 20.0, 7.8 is the volume displacement. That's the volume of the 25 pennies. If you want to figure out the volume of 1 penny, take the 7.8 and divide it by 25, okay? Before you do that though, you need to take those pennies before they get wet and weigh them all together. And you get the mass of all the combined, the collective pennies. And maybe you get a mass of the 10 pennies of about 30.5 grams. Okay, 30.50 grams. Well, if you have 10 pennies, then one of the pennies is 30.5 divided by 10, right? Because if you've got 10 and they weigh 30.50 grams, then 1 penny weighs 30.5 divided by 10. So keep that in mind, that the individual pennies, depending on how many you have, you got to take the total mass and divide it by 10, the total volume and divide it by 10, or the total volume and divide it by 25, if that's how many pennies that you actually have in your collection. So this part right here is just determining the density of the pennies by determining the mass and the volume right here. And then this, you actually are going to look at the pennies, okay? You're going to, I'm not going to ask you to cut the pennies, because in your chemical kit, we do give you pieces of pennies, okay? We give you chopped up pennies. So just take those and look at it, look on the inside and see whether there's a difference. Are the older pennies, the old pennies in the inside look the same as the new pennies? If they are, then you can't really draw a conclusion about that. But if they look different, then you can say something about what the compositions of the pennies might be in the interior. Okay. And then the last thing that you want to do is you want to take some vinegar, and you guys can use a kitchen vinegar, that's fine. Or there's some vinegar for you guys in the lab kit. Put it in a petri dish and put the 2 pennies, the old and the new, side by side, the ones that are chopped up, not the pennies that are not chopped up, because the acid needs to react with the inside of the pennies. And then let it sit for about a minute or two. And then after a minute or two, look at what's going on. If there's bubbles, it means that the acid, even though vinegar is a weak acid, is reacting with the metal. If there's no bubbles, basically it means that the metal is inert and it's not going to corrode over time. Okay, so the bubble tells you that there's a reaction going on. It's actually breaking, if there is bubbles, then it's breaking the metal to hydrogen gas and it's dissolving that metal. So those are the 3 things that you guys are going to be doing. You guys are, well, 4 things. You're going to write a new hypothesis. You're going to be determining the pennies of the new ones and the old ones. You're going to be looking at the inside of the old ones and the new ones, and then you're going to see whether a reaction occurs. So let's change this right here, and let's see about this data sheet. Okay, this data sheet is right here, and this is what you want to do. This is where you would write the hypothesis. Mass of the 25 pennies. If you're not doing 25 pennies, then just cross that out and put 10. Okay, but if you can do 25 pennies, the more pennies that you weigh out, the better your accuracy. If you don't have 25, do 20. If you can find 20 of each. But if you can't, at least 10, at least 10. The volume initial, remember you're filling the graduated cylinder to about 20, 20.0. To the 10th is 1 digit past the decimal. And then you put in the pennies, the volume final. And then the volume of the 25 pennies. That's just this difference right here. Okay, you do it for the pre and the post. Then you go over here and it says right here, the average, the average means that you take the total right here. Let's go back to the previous. So this is the volume of the 25 pennies. This is the volume of the 25 pennies. If you take that volume and divide by 25, then that's the average volume. If you have 10, then you need to divide it by 10. And then the average mass will be the total mass divided by how many you have. And then you just take the average mass and the average volume and you get the density, because density is mass over volume. Okay, mass over volume. Make sure that you weigh these things correctly, because you should have a density that is indicative of the type of metal that you are weighing, that you have. So if these two are different, then definitely the metals that make up these pennies are different. But if they're the same, then it might be the reason why your graph is anomalous, weird, is because maybe the size are different. Okay, they made the newer pennies smaller because they want to save on the metal, but that's for you to figure out based on the data. Now, show one sample calculation of the average volume and the average mass. That's just taking the total volume and divided by how many you have. Use the correct number of significant figures. Then you're answering these three questions. Describe the inside of the pre-82 and the post-82 pennies. Anything like before 1980 and after 1985 is fine. Describe your observation of what occurs when the pennies, the old and the new, are exposed to not hydrochloric acid, because we've changed that. I should have corrected that. It's acetic acid. Okay, we're not using hydrochloric acid because we don't trust you guys with hydrochloric acid. Hydrochloric acid is sort of nasty, even though we don't give you a lot. We just give you plain vinegar. Vinegar does the same thing. And then based on the observation, experiment, calculation, write a conclusion for this part. Okay. And create a flow chart. And the flow chart is similar to what I gave you. Like I actually give you a flow chart here, right there. Except now, be specific. What is the observation that you have? What is the hypothesis that you did? What are the experiments that you completed? What is the conclusion that you've drawn? So this is a flow chart, but I need you guys to be specific to this experiment. Okay, so that's that last question right here. And then that's basically it. That's basically it in terms of that. Pay attention to these right here, because these are where you want to take photos. You're going to take a photo so that you have proof that you're doing this experiment. There's 2 photos that is required in this lab. Take a photo of 10 pennies in the weighing pan or the weighing boat on the digital scale, and then take a photo of the pennies submerged in the graduated cylinder. So when you're doing these experiments, you need to take a picture with your camera phone and then upload it. So let me show you where that is found in Canvas so that you can see. So this experiment, I don't give you a pre-lab. There is no pre-lab in this experiment because I want to ease you guys in terms of doing this experiment. And there is, all you do is fill out these data sheets. Okay, you just fill out these data sheets. Other experiments will have a pre-lab and a post-lab. like this next experiment, there's going to be like a pre-lab and a post-lab, but this experiment number 1, I just want to ease you in on that. Let me show you where to file these things in Canvas. So when you are in Canvas, you want to go to that section in the course, always go to module, and then you want to go to week 2, week 3, because this is week 3, and then you want to do this right here is just the information. If you want to see my pre-lab discussion from the previous lab, you can certainly do that. If you actually want to watch the pennies rather than do the experiment, you can just open this up and then you can see the reaction of the pennies. Okay. And the resolution is poor just because back then we didn't have a thing as 1040 film, but you get the idea. It shows you what's going on. Anyway, these are pre-lab discussion from the past. Let me show you where you guys need to file this experiment. You need to file it right here under part B. And there's going to be, let me do a student view. Okay, under student view, you guys are going to see this. There's a submit button right on top here. Okay, so these are just the directions for the experiment, the data sheet. You guys are completing these, so you can download it and then fill it out. But right here under submit, click on that. And then right here is where you would browse for your file, upload it, okay? Depending on how many pages, you can do more than one page for this one, and then submit. And that's how you file your report. So in these experiments, you actually are writing it in the paper. You're not filling it in like the activity. And then you upload your experiment. Also your photos. You also need to upload your photos. Okay, so just browse for that file in your computer. Take a picture, upload it to your computer, look for it. When you browse for it, upload it with the photos, and then submit it. If you're not ready to turn it in, then don't click submit. Just have everything ready, and then when you are ready to turn everything in, then this is the page that you will do so. Are there any questions on that? I hope that's clear in terms of what you do for your first experiment. Okay, the lessons for this first experiment, really, do we write in pencil? Try in science, when you're doing an experiment, you really want to do it in pen. Okay, because it needs to be permanent. And if you make a mistake, the way to correct a mistake when you write in pen is just draw one line through your error and right below it or right next to it. Because you find out if you go into your more advanced courses that when you're keeping a lab notebook, maybe that initial entry was the correct one. When you start scratching it so you can't see it again, then you've wasted time. By just drawing a simple line, it means that you could ignore it, but it's still there if you want to see it. And then write the new entry. Okay, practice using a pen. Wow, what is your preferred, PDF or Word? PDF actually would be best. So if you have Word, okay, maybe you have a Word document, because a lot of these things are available in Word. Then if you guys have a Mac or even a PC, when you save it, you can save it as a PDF format. Okay, so in a Mac, it's super easy because you can just do save as, and then you go to the menu and say PDF, or you print it, and the print will give you the option of saving it as a PDF. I'm used to a Mac. I'm a Mac person. If you have a PC, I can't help you. Any questions after that?